So another Boolean algebra to solve. So just the same format as ever. So simplify the following expression. So this one, when it was in the exam paper, this caused a few little issues for a few people, mainly because they didn't quite get the last mark for the correct answer, not so much because they couldn't reduce it. But anyway, let's have a look at this one. So there's a number of ways you could do this. You can probably already identify there are some things here that are redundant, but let's start with De Morgan in the middle. So we could do a bit of De Morgan here. So that means we're going to change that to a plus, and then on either side we've got this sort of arrangement. Like that, and I'm going to end up with two lines on the top there, and A and still not B or naught. So we've split the line in the middle, we changed the sign. We can now look for double negations, and we've got two there. So let's write down that, our negation. So we've got A or not B or naught, or not A and B or B, like that. So we can then start to think about what other things we can lose from here. So we've done a De Morgan here, and we've done double knots. So then let's look at this one. So B or B is the same as B. So we can replace that with a B. So we've got not A and B. And on this side, not B or naught. So if we've got not B or naught, anything with naught or is going to be the same as B, so that's the same as not B because we've got the not bar above it. So we've got A and not B, or not A and B. And we've arrived at as far as we can go here, but to get the actual last mark for the answer, we need to recognize that this is XOR. So this is A XOR B. So we need to recognize that idea that this is an XOR. So if we're not completely sure about that, we might decide to carry on and try to go further. A lot of people in the actual exam tried to carry on, tried to go further, realized that they couldn't, and ended up with an answer of 0 or 1 or something that didn't really work out. So we could do a logic gate to show that this is XOR. So if we have A and B like this, then we've got not A here. So we could put a not gate in there for not A. We've got a not B on this side, just like that. But then we've got an AND gate here. So it's A and not B. So we need to have another AND gate, A and not B. And then on the other side, we've got not A and B. So not A is going to go into there. B, let's just loop over that and go into there, like that. And then finally in the middle, we've got an OR. So there's our OR gate. Like that. So the only thing I didn't show very well was the fact that that loops over it. So draw that one in blue perhaps. Like that. So they loop over each other. So we get this idea of A and not B, or not A and B, and that is the same as XOR, and this is the logic gate for XOR. And so that's that one. It did cause a few issues. Not too many people in the exam actually got this idea of XOR.